Hi guys, welcome to Product Design. What I'm going to do is just give you a quick overview of the course and then we're going to do a little activity. Okay, so the course is broken down into three sections. We've got paper 1, written exam, worth 30%. That's a 2.5 hour paper. And then paper 2, it's 20% of the final mark. That's an hour and 30 minutes. In addition to that, we've got the other 50%, which is made up of a non-examined assessment, NEA, which some of you may know as the coursework. That is made up of practical activity as well as coursework portfolio. Essentially, the course is a blend of designing and technical making principles. So what kind of practical lessons will you do? We'll be doing some 3D printing, laser cutting. Both of those facilities are going to be invested in over the next few months. So we'll have roughly 8 3D printers, 2 laser cutters in the department. We'll be doing some professional virtual modeling in 2D and 3D CAD. So we'll be getting some new CAD software, either Fusion 360 or SolidWorks, which is professional software that you would use at university or in product design engineering careers. Basic hand tool skills for engineering, including sheet metal work. So the type of thing you'd be doing if you were going to embark on an apprenticeship. Brazing, which is welding. Casting. Material testing and heat treating of metals. We're doing modelling, moulding, turning on a metal and wood lathe, steam bending, and there's loads more, but that's just a little bit of an insight into some of the things we'll be doing. So there are some maths and science skills involved. I'll let you read through these. I'll give you a few moments. So the level of these skills is going to be somewhere between GCSE and A level, with a bias towards GCSE. So you need to be either good in these areas or willing to develop. So the activity that we're going to do is the following 2 questions. And what we're going to do is try and answer them as best as we can after having watched a little video. So the first question is, what is the impact of robots being used in manufacturing plants like Tesla? And how can companies reduce their carbon footprint? And why is this important?
Tesla is by far one of the most successful companies in modern history. They popularized fully electric cars and created a massive demand among the public. With a market cap of around $380 billion, Tesla is growing by the day. But to keep up with orders, Tesla built a futuristic facility called the Gigafactory. Today, we're taking a look inside the Tesla Gigafactory. Tesla currently produces about 350,000 cars a year, far fewer than the public demands. But they have ambitions to ramp up production to more than 20 million cars a year. This bold strategy will require numerous advances in their current chain of production, including several larger factories, which are currently being built all over the world. But the bedrock of Tesla's production line is their Gigafactory in Sparks, Nevada. The company's first fully built factory will serve as the model for what eventually could be a dozen massive Tesla factories globally. In order to transition the world to sustainable energy, we really needed to build this big, build this boldly, and really build as many battery cells as we possibly could to really accelerate this transition, Chris Lister, Tesla's vice president for operations, told CNBC. Only about 30% of the factory is currently built out, but upon completion, it could be the world's largest building by footprint. Tesla, meanwhile, said US orders for the Model 3 had outpaced its available output for the past 2 years. The Gigafactory, which is open around the clock, currently has 7,000 employees. The Gigafactory cranks out approximately 2 battery packs every minute. Its production is currently estimated to be 5,000 a week, with room to grow, according to Sam Jaff, managing director with Cairn Energy Research Advisors in Boulder, Colorado. JAF studies the electric vehicle market, specifically focusing on the costs to build the battery packs and cells that provide the energy inside those packs. JAF's analysis pegs Tesla's cost to manufacture a battery cell at $116 per kilowatt hour, which he says is far ahead of the industry. He estimates other automakers building electric vehicles have battery cell costs close to $146 per kilowatt hour. Tesla's Project Roadrunner aims to reduce costs to $100 per kilowatt hour by 2021. Tesla has shown an ability and a drive to reduce both cell costs and battery pack costs, he said. They have been planning for this moment with this tremendous cost advantage for a long time, and in general, they have executed well on it. That's not to say there haven't been growing pains at the Gigafactory. Tesla initially partnered with Panasonic to produce its proprietary batteries. Panasonic claimed they could increase energy density within Tesla's batteries, and after years of allegedly fraught relationships between the two companies, they recently inked another deal that is due to last until 2023. Panasonic is not Tesla's exclusive battery supplier anymore, since they began partnerships with LG Chem and CATL to supply cells in China. Working alongside the factory's 7,000 human employees are a team of super smart robots. The automated robots can move materials between workstations faster and lift heavier loads while staying charged for 19 hours. Some of the robots navigate through the factory using digital maps. An employee expanded on that, saying, "They're really on a fixed path, so it's very predictable. They're going to the same locations, picking up from one location and emptying off at another location. And what it allows us to really do is to have things moving from inventory to line side all day long without a whole lot of human intervention at all." Gigafactory 1 is aligned on True North, which was done so that the equipment can be mapped by GPS and solar panels on the roof can be accurately aligned. The factory has also been designed to become entirely energy self-reliant. Tesla intends to power the structure through a combination of on-site solar, wind, and geothermal sources. When completed, the building will have the largest footprint in the world and the second largest volume. Though Tesla has faced scrutiny for wastefulness within the factory, its master plan includes many energy-saving features. For example, excess heat from equipment such as compressors and high-temperature ovens will be able to not only run equipment efficiently, but to help keep the factory warm in the colder months. The roof will eventually contain 200,000 solar panels. These will expand across 1.8 million square feet of the factory. The location is a key component of the Gigafactory's ability to use solar energy, as it's located in a desert that gets a large amount of sunlight. Tesla's Gigafactory also has a water cooling system that repels extremely low temperatures. Because of the way the air is here in Nevada, it's dry and really hot during the day, but it's very cool at night. We do have a 10 million gallon water tank out back, and it allows that water to cool down. We use it for air conditioning. A lot of the equipment requires chilled water to operate to keep it running, said Lauren Cito, a Tesla employee. Tesla's Vice President of Operations, Chris Lister, also spoke in the video. "We really wanted to get to a point where this is going to become a fully net zero facility, leaving zero carbon footprint, creating products that also leave zero carbon footprint." Nevertheless, Giga Nevada has turned a profit for the first time in 2020, thanks in particular to the substantial increase in demand for Tesla cars. For Panasonic, this means that their investment of $1.6 billion in the Nevada plant is finally yielding returns, roughly 3.5 years after entering full production. When construction began in 2015, it appeared that Tesla was risking everything on the Gigafactory 1. It would churn out the batteries necessary for the Tesla Model 3, which is the car that was supposed to make or break the company, and for which Tesla already had hundreds of thousands of orders despite first deliveries still being more than a year away.
Okay, so back to the questions. What is the impact of robots being used in manufacturing plants like Tesla? Then how can companies reduce their carbon footprint, and why is this important? Off you go.